Alright guys, welcome back to the channel. So this question says a groove foil is 0.08 millimeter thick and 670 millimeter square in area, and the structure is cubic with a lattice parameter equals to this nanometer and how many unit cell. So we have to look for two things. First of all, we need to take in our parameters given. So we know our thickness. So we are giving thickness as 0.08 millimeter. We need to convert this millimeter into centimeter because our density is given as centimeter cube. So it's going to be able to like divide itself. So to go, we just go back once. So when we take this once, we have a stop here and a zero. A stop here and a zero. So it becomes equal to 0.008 centimeter. Right? Okay, for our area, which is 670 millimeter, because it is square and we are going to centimeter square, so we are going back twice. So go back 1 centimeter, another centimeter, that's twice, so it becomes equal to 6.7 centimeter square. Remember, we went back twice here because it is centimeter square, and we went back once here because it's just centimeter, not a square. So we are given our lattice parameter A, which is equal to 0.4076 nanometer, which is equal to 0.4076 times 10 raised to the power minus 7 centimeter. Right. So the next thing we need to know is, we know that for volume on a regular day is equal to length times breadth times depth or thickness. You can call it depth or thickness. So area, these two alone are our area, times our depth, in which the depth is also our thickness. So given our area as 6.7 centimeter square times 0.008. Remember I said depth is the same thing as thickness. So therefore our volume is equal to, when we punch this into our calculator, we have 0.0536 centimeter. This is our volume of the foil. Let me erase this. So volume of the foil is equal to this. So next we have to look for the volume of a unit cell. So given that our A is equal to 0.4076 times 10 raised to the power minus 7. So therefore our A cube, volume of a unit cell, where V, volume of a unit cell is equal to A cube, so it's going to become 0.4076 times 10 raised to the power minus 7 cube, where our volume of unit cell is going to be equal to 6.774 times 10 raised to the power minus 23 centimeter cube. So here is the volume of unit cell. Next, we now have to look for the number of unit cell in the foil. So number n of unit cell in the foil, is going to be equal to our volume of foil over our volume of unit cell, in which we solve for both. We have our answers to be volume of foil is equal to 0.0536 centimeter over, sorry, this is volume, so it has to be cube. This is volume, it has to be cube, take note of that. Then centimeter cube, right? Centimeter cube over, this is 6.774 times 10 raised to the power minus 23 point, yeah, that's centimeter cube. First of all, these two cancel each other, so therefore our n is going to be equal to, when we punch that into calculator, we should arrive at 7.915 times 10 raised to the power 20. So this is our number of unit cell in the foil. Next, we have to look for mass of, what's the question again? Sorry, what's the question? I say we should look for the how many unit cells are there in the foil. So mass of each unit cell. Yeah, so this is answer for I that says we should look for the number of where's it number, how many unit cell are there in the foil. So we found that. So number 2 says we should look for, question number 2 says we should look for mass of each unit cell. Mass of each unit cell. So therefore, mass of each unit cell, for mass of each unit cell, we need to know or remind ourselves that density is equal to mass over volume. Therefore, mass is equal to density, making mass formula. Sorry, let me write my density well. Density times volume, right? So looking for the mass of foil is equal to, what's our density? We are given our density as 19.32 in the question, gram per cm cube. This was the reason why we changed all our parameters into centimeter cube, multiplied by our volume of foil. So this is mass of foil, don't forget. So we have multiplied density of foil times, this is density of foil and foil. So our volume of foil is from here 0.0536 centimeter cube. So this centimeter cube cancels this centimeter cube, right? So when we multiply that, it becomes 1.0363 gram mass of the foil. So this is mass of foil. So we have to look for mass of each unit cell. So therefore, mass of each unit cell is equal to, we say mass of foil over the number of unit cell in the foil. So therefore, our M of unit cell, mass of unit cell is equal to, what's our mass of foil? We have it to be 1.0363 over our number of these, which is 7.915 times 10 raised to the power 20. So therefore, our answer for mass of unit cell, sorry, let me read this out. Mass of unit cell is equal to 1.31 times 10 raised to the power minus 21 gram, since it is mass, right? So therefore, this is our mass of unit cell. We're told to look for this mass of unit cell. This is our number 2. This is our I, and for our I, this is our I. Alright guys, make sure you subscribe to the channel. Thanks and bye.